Lesson 17 through 18 is all about the slope-intercept form, which is essentially just taking an equation and turning it into a particular form and then using that to graph. And it makes it a lot easier instead of having to use t-tables in order to graph an equation. So let's start with what the slope-intercept form is. So the slope-intercept form is y equals mx plus b. Now the only two things that will change is m and b. We've already talked about in the other lessons how m is your slope. So that's going to tell you how much you go up and how much you go over. Now b is new for us. B is your y-intercept. It's your starting point. So b is going to tell you where on the y-axis the line crosses, and then from there, because that gives you a point, from there you can use the slope to go up and over or down and over wherever you need to go according to the slope. So let's take a look at some examples. This first example, we have y equals 2x plus 3. So the slope in this case is 2, and the y-intercept is 3. And that's all the information we need. So we don't need to make a t-table in order to graph this. This is going to be much simpler. So our y-intercept is 3. So that tells us that the line crosses this y-axis at 3. So there is a point at 0, 3. Now remember, I told you that you only need 2 points in order to draw a line. So we have one. All we need is one more point and we can draw our line. Now our slope says it's 2. Now it's just not 2, it's actually 2 over 1. So that means we go up 2 over 1. And there's our second point. And if we could draw a line from that, or if we kind of want to get more points, we can, because this is going to be patterned. Constantly it's going to go up 2 over 1, and vice versa in the other way, down 2 to the left 1. And we can use that to get a couple more points if we want our graph to be a little bit more precise. So now we can draw our line. And we, of course, always put arrows at the end because the line goes on for forever. And so that is that first one. Let's take a look at our next example. So this is y equals 1/2 x plus 2. So our slope is the number that's always in front of x. So in this case, it's 1/2. And our y-intercept is 2. So we'll start at 2, so because the y-intercept is 2, so we start at where the y on the y-axis is 2, so right here, so we have a point at 0, 2, and now we only need one more point to draw our line. The slope says we go up 1 over 2 because it's a half, so we go up 1 over 2, and we have our second point. Now we could draw a line from that, or if we want a couple more, just continue on, up 1 over 2, up 1 over 2. Okay? Getting 3 or 4 points helps us make it so our line's going to be more precise. But now we can draw our line. So hopefully you can see that that is a lot faster than making a t-table, choosing some numbers for x, plugging it in, and finding y. Because all we need is to know where we're starting and then where we go from there. So now that we know how to draw a graph from an equation, we need to go the other way. We need to take a graph and figure out what the equation is of that graph. So let's take a look at our first example. So remember, we're going to put it into this y-intercept form. So we're going to put it into y equals mx plus b form. So all we really need is m and b. That's it. And then we'll have our equation. So we can figure out either one first. It actually really doesn't matter. So maybe we start with m. M just says how much up, how much over. So if we start from this point here, let's see, it looks like I have to go up 4 and then over 3 to get to my next point. Well, up 4 to the right 3 is 4/3. So my slope is 4/3. And then b is our y-intercept. So where does it cross the y-axis? It crosses the y-axis at 4, at positive 4. And that's it. That's our equation. Our equation is y equals 4/3 x plus 4. That's it. It's really that simple. Let's take a look now at a negative slope, but it'll still be the same thing. So once again, we want to write y equals mx plus b. but we need to know what our slope is and our y-intercept. So let's start this time with the y-intercept. So where does it cross the y-axis? Well, let's see, it crosses at -1, -2, -3, -4, -5. And then what's our slope? Well, if I start from this point, and remember, we could use either points. It looks like I go up 1, 2, 3, 4, 5. I go up 5, and then I go to the left 2, which is a negative. And we could leave it like that, or we could rewrite it. Now, here's the interesting part. You can either leave it as adding a -5, or you could change it to minusing 5. These both are going to be the same thing. Now, sometimes we're going to want to graph something using the slope-intercept form, but they don't give us slope-intercept form, so we have to change the equation they give us to be slope-intercept. So really, all that we need is y on one side equaling x and then whatever's left over. So we can manipulate equations, whatever equation they give us, to be into y-intercept form. So essentially, we just need to solve for y. So let's take a look at this first equation. If I want to solve for y, I need to get rid of everything else around it. So I'm going to get rid of the fact that I'm adding 2x by subtracting 2x. So I'm going to subtract 2x from both sides. And these can't combine because they're not like terms. The last thing I need to do now is, or the next thing I need to do, is get rid of the fact that we're multiplying by 3. We're going to do that by dividing by 3. Now, when we have it like this, we can kind of break it up so both of them are over 3. Now, it's looking a little closer, but normally you put x first. So let's move it over. So the negative sign stays with x. And we, of course, can simplify 3 over 3 as 1, and it's positive. So this is an equivalent equation to what we started with. Just now it's in our slope-intercept form, so we know that, oh, this equation starts at 1 on the y-axis, and then we're going to go up 2, down 3, because it's a negative slope. Now let's take a look at this equation. So we already have y by itself, but it may not be in the form that you like. However, if you're comfortable with this, you could actually leave it like this because you recognize that, oh, I have y on the other side, but it's still the same thing. The reason I wanted to put this here is just so that you get comfortable with looking at this, but if you really want to mix things around, if you really want to just kind of change what's on what side, so it's still y equals 8x plus 7, you can. But if you can look at this and notice that, oh, 8's my slope and 7's my y-intercept, you're ahead of the game. Lastly, we're going to look at how this applies to word problems. Now, the reason I like teaching slope-intercept first is because it really is the simplest, and we've kind of already worked a little bit with this kind of form, y equals mx, now we're just adding plus b. So let's take a look at this word problem and then write an equation based on that. So it says a bulk buy store has an entrance fee of $5. The granola costs $3 per pound. Write an equation that shows the total amount of money that you have to spend per pound of the granola, and then we need to graph it as well. So if we need to write an equation, all we need is y equals mx plus b. Where remember that our m is our slope, and our b is our y-intercept. Another good way to think about the y-intercept is it's our starting point. So we essentially just need to figure out our starting point, and then essentially what our rate is, how much we're being charged per something, how much something's happening per time, and on and on. And those are the only pieces of information you need to know in order to write an equation. So we need to write this thing all over again, but just now from a different form. So we can start with either our intercept or our slope. Well, the first thing they tell us is that there's an entrance fee of $5, okay? There's two pieces of information here. Entrance fee of $5 and then $3 per pound. Well, all we need is to fill in each of those somewhere. We just need to know which one goes where. There's an entrance fee of $5. That sounds a lot like a starting point. Right off the bat, you walk the door, you have to pay $5. So that's our starting point. That's our y-intercept. Now, the cost of granola, that sounds like a slope. That's a rate. Because for every pound, I have to pay $3 more. So my rate is 3. So there's your equation. It's that simple. But now we just need to graph it. So right off the bat, I have to start with spending $5. So On this graph, maybe we want to do, let's see, because if we do 5, it's going to be up here. So let's start with let's do these boxes are every 2. So here's 2, 4, 6, 8, 10, 12, 14. I apologize, I probably should have put a different type of graph on your paper. So starting off the bat, we have to spend $5. So we've bought no granola and we spent $5. So at 0 pounds of granola, I'm spending $5. After 1 pound of granola, well, our slope tells us that we're going up 3 over 1. So we need to be careful here. So I'm starting at 5. If I go up 3, I go up to 8 and then over 1 pound. So you always have to be careful of what the units are that's happening so you're not going up 3 spaces when actually here each space is 2. So really, on this graph, if you're going by the boxes, I'm going up 1.5 over 1. And that's enough for us to draw our line. Now, I know a lot of you are probably thinking that we really don't need to pay attention to the negative side of this graph, and you're absolutely right, because obviously you're not spending negative money, you're not buying negative amount of granola, but in all fairness, this is the line that goes along with that equation. So for it being applicable, you of course can keep with one quadrant to show the positive, or you can draw the whole thing. It won't really matter. And that is it for lesson 17 and 18.